Now, obviously nothing is going to cancel at this point. Remember, you cannot cancel the 3 into the 9 until you factor. You have to be able to cancel it out of everything. So if you want to go ahead and factor a 3 out of the bottom, and I know you can factor out a 9, but for purposes of canceling the 3's, this is what we would have left. If you decide to cancel out the 3's, you got to take a 3 out of all the terms. So this is what we'd have left. Now at this point, nothing else is going to cancel there. However, you do know that cosine squared can be rewritten. Who remembers how cosine squared can be rewritten?
Isn't it 1 minus sine squared?
It is 1 minus sine squared. So if I do that, 1 minus sine squared, then there's hope at least that I'm going to be able to do some canceling, because I can factor both the top and the bottom. So the top is the difference of squares. That's the beauty of this expression. It is always going to be the difference of squares, and therefore it will always factor. So if I factor the top as the difference of squares, pull a 3 out of the bottom, look what happens. And then I can see that my answer is 1 plus sine over 3. So that is what you should end up with on that problem. Now, skipping to the next circled problem, which is writing the partial fractions. I think I did this the other day. I'm not sure which class I did it in, but let's try it in yours. I need the partial fractions. So step 1 is you are going to factor that denominator. Obviously, it's important that you factor it correctly, so you might want to take a double check and make sure that you've got the right factors there, FOIL it back together. Those factors become the denominators of your partial fractions. Remember, when you write or when you find the partial fractions, what you're really doing is finding the 2 little fractions that are going to add up to the big fraction. So the common denominator of these is that. So that's what we're doing, is splitting it up. Now, that equals the original problem. So if I multiply everything in that equation by x minus 3, x minus 2, all that's going to cancel. This is going to cancel, and this is going to cancel. So I just cleared out my fractions. Now, I have left, all the denominators are gone. All I have left is ax minus 3a plus bx minus 2b equal to x plus 2. All the denominators have disappeared and part of the numerators. Now, in this equation, the x's on the left have to equal the x's on the right. In other words, a plus b has to equal 1. A plus b has to equal 1. And the unboxed pieces are equal, so negative 3a minus 2b equals 2. So now I have a nice little system of equations, and I'm going to solve that using, I'm going to use elimination. You can do substitution if you wish, or Kramer's rule, whatever you want to do. I'm just going to multiply the top row by 3, so I have 3a plus 3b equals 3. And negative 3a minus 2b equals 2. So b equals 5. And it looks like if b is 5, plugging back in, a would have to be negative 4. So unlike other times when you do substitution elimination, don't write your answer as an ordered pair. Your answer is the partial fractions. So it'll be negative 4 over x minus 2 plus 5 over x minus 3. Make sure that you get your a over your a denominator and your b over your b denominator. And this is the answer to the question. Now, the next one isn't circled, but some of the other classes don't need to find all the parts. So I thought we would go through all the parts of number 14. Okay, now notice that you're not asked to graph it. So when we did these before, you had to graph them. You're not graphing this, you're just going to list the information. So there's my equation right there, and I need to do amplitude period, phase shift, vertical shift, and frequency. Now, remember that this number right here, for a sine or a cosine, that number is the amplitude. None of the other functions has an amplitude. So as long as it's a sine or a cosine, the absolute value of this number is going to be the amplitude. So if that had been a negative 3, the amplitude would still be 3. Nothing else other than sine and cosine has amplitude though, because amplitude refers to height, and all of the other functions have no height, just sine and cosine. The normal period of sines and cosines is 2 pi. But when you have put a coefficient on the x, that divides the period. So the period of this function is 4 pi. 2 pi divided by a half. The period of a sine and a cosine is always 2 pi, the base period. That number divides it. Phase shift is your horizontal shift. It is sometimes referred to as horizontal shift. You should know enough about functions, translations of functions, to look at that equation and say, this thing has been shifted x over 4 to the left, or you can say negative pi over 4. I said x, I meant pi over 4. Pi over 4 to the left, or negative pi over 4. That's how that picture has been shifted. And its vertical shift is 2, or you can say up to, whatever you want to do. That one's gone up to, positive 2. Frequency is simply the reciprocal of the period. When you write that frequency, make sure that you have 1 over 4 pi. Make sure that pi is in the denominator along with the 4. The only other problem that is circled is number 21. It says if you have 8 kids, what's the probability of exactly 3 boys? Now, this is binomial probability. It's like a coin toss. It's like guessing on a multiple choice test. Because every time you have a baby, it's a boy or it's a girl. It's a boy or it's a girl. Each time is like a new problem. Just like each guess or each roll of the die is a new problem. So we're going to have 8 children. We're going to pick 3 of them to be boys. The order doesn't matter. That's why I'm using C. I don't care if it's boy, 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 and then all girls, or if the boys come at the end, or if the boys are mixed in. Doesn't matter. I just want 3 of the 8 to be boys. The probability of a boy is 1/2, and the probability of a girl is also 1/2. Now, if you're confused about those exponents, please don't be. It makes perfectly good sense. We want 3 boys, and if we're having 8 kids, we gotta have 5 girls. So the probability of a boy and a girl are the same, roughly speaking for our purposes, so that's going to be the answer. So I need to type that in on my calculator carefully. I suggest if you have a calculator that maybe you just practice typing this in, because you're going to have to do that on your test. And I got 0.21875, or about a 21.9% chance of having 3 boys if you have 8 children. Everything else on that worksheet, on this worksheet, is videoed and the answers are posted. So I'd like to look now at the first review sheet, and it has these very same problems on it, or this very same kind of problem on it. But let's look at the other review sheet now, which I don't have totally videoed, and let's see what kind of questions you came up with as you started preparing for this exam. We are now on the first review sheet, not the one that says number 2, but the other one. Who found something that you want to look at again? Shout it out, please. Has the same 28 problems on it as the other one. They might be in a little bit different order. Maybe not. Maybe they're in exactly the same order. Pretty close to the same order. All right, so who's got something?
Can we do some of like the log problems?
Well, I know there are a couple of logarithmic equation problems. So number 4 has a couple of logarithmic equations. This one and this one. There's also, I see another problem that uses logarithms, so we'll do that one. And then I don't know, we'll just have to see if there's any others, I can't remember. All right, so this is a logarithmic equation. We're going to solve it. 4 to the 3rd equals x. Kids, just one of the vital pieces of your life experience in mathematics, you got to be able to change this into an exponential. So 4 to the 3rd equals x. So x is 64. 4 to the 3rd equals x. Now, that's easy. You can't do that with this one because there's too many logarithms. So the first thing we got to do is put these 2 logarithms together into one. Now, so instead of having 2 logarithms, we're going to have 1. Now, since that's a minus, they're going to go together as a division. If it were a plus, you would still put them together, but you would put it together as a multiplication. Now, that equation looks different than this one. This one did not have a logarithm on this side. This one has a logarithm on both sides, so you're allowed to disregard those and just set this equal to this. 2 things. You can't do that with this problem because there's no logarithm over here. This one you have to do 4 to the 3rd equals x. You cannot drop the logarithms until you have 1 equal to 1. Do not drop the logarithms in the original problem. You're going to miss it. You have to have 1 equal to 1. Then, once you have your equation, you'll solve it like a regular equation. So it looks like x equals 3/4. Okay? Now, the one that uses logarithms would be in that same section, letter E. How do I know it uses logarithms? Well, look at letter D. Letter D has a 4 and an 8, and they can both be written as powers of 2. But letter E has an 8 and an 11. They cannot be written as the same base. They're not both. This is a power of 2, but this is not. So the only way to solve that is to take the logarithm of both sides. Because when you take the logarithm, the exponent will come out in front. And now you can solve for x. So I would probably divide by the log of 11, or excuse me, the log of 8. And then subtract the 1. There's other ways you could solve that. That's just how I would do it. You could distribute over here. Subtract first and then divide. That would be fine. It doesn't matter. We all should get the same answer. About the only place you can go wrong here is, don't forget you got to close that parentheses around the 11 before you hit log 8. And then you got to close it around the log 8 before you do minus 1. So I got 0.1531 as my answer. So again, your steps might be a little bit different in here, but make sure you're getting that answer. Okay? Who has something else you want to be sure that we look at today? Rory, put your camera on, please.
Can we do number 6?
Number 6. How many radians is 500? Remember that pi over 180 equals radians over degrees. So pi over 180 equals x over 500. So 180x equals 500 pi. So x equals 500 pi over 180, which is 25 pi over 9. That's all there is to that. You just got to remember there are pi radians and 180 degrees. So there are x radians and 500 degrees. Set up a proportion and cross multiply. All right, who else? Anything else? Okay, I don't want to waste time, so I'm just going to start doing problems. I want to make sure we hit what you need to practice. All right, let's look at some trigonometry problems. Let's start with number 9. 9 says, find the area of these triangles. So these are both really easy problems if you remember how to find the area. Make sure I'm on the right quiz. I am. So for that first one, A there, we would want to do the Hero's formula. So we'll start by finding the perimeter. The perimeter of the triangle is 36. Did I add right? So the semi-perimeter would be 18. So when I find my area, I'll start with 18, and then I do 18 minus each side. So 18 minus 15, 18 minus 10, 18 minus 11. I multiply those four numbers together and take the square root, and your area is 54.99. If I had units, it would be whatever, squared, inches squared or whatever. That's the area using Hero's formula. Now, Hero's formula will not work on this next one because I don't have all three sides. I could find the third side, but that would necessitate some rounding off, and that would be a lot harder than just remembering the area is 1/2 side times sine of included angle. That's it. I don't have to do anything but type it in. 1/2 times 16 times 13 times sine 58. And I got 88.20 for the area of that triangle. Now, number 10 is similar, except it's not finding area, it's finding side A. So what we need to remember is that when we are finding sides or angles, we need to use either the law of sines or the law of cosines. So, since I have a pair here, I'm going to set up my law of sines proportion. Sine 72 over 10 equals sine 58 over A. And then I will cross multiply and divide in either one step or two, however, whatever I'm comfortable with. And then I will type that in on my calculator, and that is side A. Remember that you use the law of sines or cosines when you have to find this, a side or an angle. Also be careful, like with the logarithms, when you type this in, you have to close that parentheses before you hit divided by. So A should end up being 8.92. 8.92. I think this is the one, I think on the answer key I posted, there's a mistake on there. There's the correct answer, 8.92. All right, number 11. This one says, how many triangles are possible? Well, we're going to start exactly like we did the last one, because if you notice, you got a pair right here. So sine 79 over 15 equals sine E over 16. Now, I know the directions didn't tell me to find angle E, and that's what I'm going to find. This is going to tell me what angle E is. But knowing angle E will help me determine, first of all, if there's a triangle, and second of all, if there's one or two. So, remember, when it's sine E, you're going to have to second sine. So whatever this decimal is, you have to second sine it, or inverse sine it. So second sine, 16 sine 79, close parentheses, divided by 15. Whoops, I got an error. I got an error here. That means that there are no triangles possible. If you got an answer, let's say we did second sine and it came up with 80 degrees. Okay, just making that up. Let's say that's what it came up with. Then I would know I had one triangle. So I would step over to the side and I would figure out, okay, if that's 80, then this one would have to be 100 because the second one is always 180 minus the first one. And since that's less than 180, there would actually be two triangles possible. What if this angle came out to be 70? Well, then this angle would have to be 110, and that would not be possible. So that scenario would have just one answer. The one I just erased would have two, and the real problem had none, because there came out to be no answer for that angle. And then I think there's one more trigonometry question, 12. Now 12 is another find, in this case, a side. So this is going to be a law of sines or a law of cosines problem. Anytime we're finding a side or an angle, we're going to law sines or cosines. If it happens to be a right triangle, you can SOHCAHTOA, but none of these are right triangles, so we're going to do law sines or cosines. Now notice, do I have a pair? No. So this will not be able to be set up like that one. You do not have a complete set, a complete fraction. C and C, no. E and E, nope. D and D, nope. Don't have it a pair. So we're going to use the law of cosines. The law of cosines says cosine 47 on this end, C squared on this end. In between is 23 squared plus 16 squared minus 2 times 23 times 16 times cosine 47. Hopefully you remember your law of cosines. If not, all this is in section 5.5 and 5.6. So you've got notes. If you've thrown away your notes, shame on you. But there's more in Schoology, so you can get those notes out and do the video, watch the videos over those sections if you've forgotten any of this. 23 squared plus 16 squared minus 2 times 23 times 16 times cosine 47 equals, tricky thing about the law of cosines, remember that's C squared. So after you get all that typed in, which is easy, just type it all in, you got to raise it to the 1/2 power. So C, or square root it. I raise it to the 1/2 power. You can square root it. Same thing, 16.82. So that side is 16.82.
Are there going to be any formulas that we get on the final?
I will give you the formulas for like the compound interest, and I will give you the same formulas I gave you the other day for the sequences in series. Everything else you got to know. So there really isn't that. I mean, you got to know the law of sines and cosines, obviously. Let's look at problem 25 because it is also a trigonometry problem. It says find the area of the regular octagon. So remember that a regular octagon has 8 sides. And this particular one has a radius of 10. And our job is to find its area. You certainly do not have to draw in all the triangles, but you can. And regardless of my picture, these are all congruent triangles. All of these lines I drew are 10, and they are all congruent triangles. So remember that you have 8 congruent triangles. So you have 8 angles here at the center that add up to 360. So 360 divided by 8 will be this right here. So all of these add up to 360, full revolution, divided by 8, 45. So each of these angles is 45 degrees. That's how we get a full revolution. So the area of that triangle, we already talked about this, is 1/2 side, side, sine. So whatever that is, when I type it in, that's the area of this triangle. So the area of the octagon will be 8 of those triangles, and that will be the answer to the whole shebang. So, got my triangle, and I'll take it times 8, and I got 282.84 inches squared. There's also an equation on this one. We already talked about this, but since it's trigonometry, I'll throw it in here. The amplitude is 4. Remember, the negative turns the picture upside down, but amplitude is height, so it can't be negative, so the amplitude is 4. The period is 2 pi divided by this coefficient. So this time, the period is just pi, 2 pi divided by the coefficient on x. My horizontal or phase shift is positive pi over 3 or right pi over 3. My vertical shift is 1 or up 1. And my frequency is always the reciprocal of my period, so it will be 1 over pi. All right, anything else you think of? That's the trigonometry. Most of it anyway, but I could find there. We'll do one of these compound interest formulas. I'll give you the formulas. But again, you'll have to know what's what, when to use what. So there are 2 growth formulas. Number 5 on the sheet. How much will I have in my account if I deposit $1,600 at 3.1% interest compounded quarterly and leave it for 25 years? That's going to be my top formula. How much will I have if I start with 1,600? Interest rate is 0.031. Regardless of the formula, whatever interest percent you've been given, you got to change to a decimal. We're compounded quarterly, and we're for 25 years. I'm going to type that in on my calculator, and it's doable exactly as it stands. I usually clean up my exponent before I start, so I'll make that 100. You don't absolutely have to. It makes it easier for me. And then I'm just going to type it in just like I see it. 1,600 parentheses 1 plus 0.031 divided by 4, close the parentheses, raised to the 100th power. And that is $3,462.59. If I were going to use the other formula, and I think that's on the other review sheet, the problem wouldn't say compounded quarterly, it would say compounded continuously. This is your continuous growth formula. While I'm here, let's go ahead and do problem D. Now this is going to be on the no calculator part. Remember, the exam has two parts, calculator and no calculator. So the things without stars, without asterisks, are doable without a calculator. You absolutely could take the logarithm of both sides and solve that, but probably not without a calculator. So we need to pay attention to the fact that we have a 4 and an 8. Those are not random numbers. 4 is 2 squared, and 8 is 2 cubed. Whenever you have a double exponent, you're multiplying. So these get multiplied and those get multiplied. And then much like the logarithm problem we did, when the bases match, once the bases match, you can set the exponents equal. And then just solve it like a regular equation. So x is negative 9/5. If you have a problem like this on the no calculator part of the test, you will have to get a common base. So the base may not be 2 that you get, but you're going to have to get some kind of common base, because that's the only way to do that without using logarithms. All right, anybody think of anything yet? All right, problem number 17 is like the boy-girl problem that we did a little bit ago. It says you're going to randomly guess 4 right. You're going to get 4 right on a 10-question test. So I'm going to start with 10C4. There's 10 questions. I'm going to get 4 right, and I don't care which 4 I get right. I'm just going to get 4 of them right. Each question, so these are the right, these are the wrong. I want 4 of these and 6 of these. 4 correct, 6 incorrect. Now, each question has 5 options. So when I randomly guess, I have a 1/5 chance of getting it right and a 4/5 chance of getting it wrong. This is exactly like the boy-girl problem. We're getting 4 boys and 6 girls. The difference is, of course, that in a boy-girl problem, these would both be 1/2. In a true-false situation, these would be 1/2. In a let's roll the die problem, this would be 1/6 and 5/6, assuming you were trying to get, a 2 or something like that. Then I'll just type that in on my calculator and get the answer. If you type it in exactly the way I wrote it, with the parentheses and stuff, you'll get the right answer. You can type it in other ways too, but if you have any kind of issues, you might want to just type it in the way that I wrote it. I have 1/5 of the 4th. I got 0.0881. As the answer. All right, let's look at the problem right under that, 19, or no, down a couple, 19. How many ways can a teacher give away a marker, book, a crayon, and a calculator to different students in a class of 24? So there are 24 kids in the class. We're giving away 24 presents, and the presents are all different. So is that going to be 24C4 or 24P4? It's one or the other, guys. We got 24 kids, and we're choosing 4 of them. Which one is it in this problem?
P.
Yep, it's P because the presents are different. It matters to you whether I give you the calculator or whether I give you the marker. That matters to you. So this is a P problem. So we would just type in on our calculator 24 P4 and write whatever that is in the answer blank. Whoop, P4. So 255024. Let's see, have we jogged anything else for anybody? All right, let's look at number 28. Again, when we did these before, they were much more involved. You had to graph it, you had to find a whole bunch of stuff. On this practice test, or practice thing, we're finding the vertical asymptotes and the Y-intercept. Check the other review, you might be finding other things, but you're only gonna find a couple of things. You're not gonna graph it. Here we go. The Y-intercept is a no-brainer. The Y-intercept is the value of Y when X is 0. So if I put a 0 in for my X's, I'm gonna get 1/9. That is how you find a Y-intercept always, always. You plug in 0 for X and figure out what Y is. Now the vertical asymptotes, they're the cannot be's. They are the things that make the denominator 0. So it's probably a good idea when you have a factorable problem to go ahead and factor it. Whoops. In this case, nothing cancels. Sometimes it does, in which case then you would have a whole. Since nothing cancels, if we were asked, we would say this has no holes. But it does have 2 vertical asymptotes. X equals 3 and X equals -3 are the no-nos. Those are the things that X cannot be. And cannot be's are vertical asymptotes. Right above that are the limit problems, a couple of them. The limit of the first one is 3/5. You got 3x over 5x, so that would be 3/5. And the limit of the second one is 0, because 4/5 raised to a power is going to get smaller. 4/5 is less than 1, so the limit of 27b is just 0. All right, has that jogged anything else for anybody? All right. Let's look at the matrix problems in number 13. So got some things there. We're going to do A plus 2B. And that is definitely doable because these are the same size. And remember, for addition, they have to be the same size. All right, so we're going to add 1, 2, 3, -5, 2, 0, 10, 8, 2. So we're just going to distribute that 2 to everything. And now add corresponding entries. So 1 plus 0, 2 plus 10, 3 plus 8, and negative 5 plus 2. And there is our sum of A plus 2B. The next one wants to know the determinant of C. So remember with a 3 by 3, you're going to recopy the first two columns in order. So 1, 2, 0, 1, 0, 1, and then multiply, 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 add them all up, and then multiply, 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 and add them all up, and then subtract the downs minus the ups. So negative 2 minus 7, the value of that determinant is negative 9. Now we're going to multiply A times B, which again is doable because this is a 2 by 2 and this is a 2 by 2. These match. My answer will be another 2 by 2. So these must match, and this tells me my size of my answer. So now I will multiply first row times first column. So 1, 2 times 0, 4, and that's going to give me an 8. And then I'll multiply first row times second column. So 1, 2, 5, 1. That gives me a 7. Second row, first column, 3, negative 5, and 0, 4, which is negative 20. And then second row, second column, 3, negative 5, and 5, 1. And that's a 10. So there is the product. And then the last of the matrix collection there is finding the inverse of matrix A. So matrix A. So remember, finding the inverse is a two-step process. First, we find the determinant. So we multiply down, we multiply up, and we subtract. So negative 5 minus 6. Negative 5 minus 6. So my determinant is negative 11. Now just hang on to that number. Make a new matrix by switching these two and changing the signs on those two. So I switch these two, this is called the adjoint. I switch these two, change the sign on those, and then I'm going to divide by negative 11. Everything. Simplify, and that's my inverse. So 5 11ths, 2 11ths, 3 11ths, and negative 1 11th is my inverse. All right, one more chance. Anybody find anything? Okay, you can, this is the lunch period, right? Let me make sure I'm doing this right. This is lunch. All right, you can go ahead and go to lunch. I'll see you tomorrow. Have a good day.